All right, back for part two, ways to express an algorithm. We could express an algorithm in words, which is most of our algorithms are in words, like a recipe for a cake is in words. Either formally using pseudocode. Pseudocode is a computer science thing, and we'll see an example of that later, but or informally using English or whatever language you're speaking. So pseudocode is a computer science thing. We could use pictures, informally using drawings or icons. You see, uh, on the blow dryer in the washroom, there's little diagrams that show you how to use it. Well, that's an algorithm. But in computer science, we often use a flow chart, which you may have seen in other courses, and we'll talk about this year later. That's a formal computer science tool. Of course, we can express algorithm as code, and that's often what we want to do. We want to code an algorithm into the computer. Often, we'll complete one or two first. If a program's worth any merit, it often needs some planning, and an algorithm is the plan behind a program. So here's some examples just to get you thinking for later. Here's a pseudocode. We talked about earlier, one of the algorithms is finding the remainder when one number is divided by another one. So here's a pseudocode. Step one is get the two integers. Step two is to divide n divided by m, and you get an answer d. Step three is to round d to the nearest integer. Call this e, and then you make a calculation, output r. So let's do an example here, just so I can show you that what we're talking about. So if we have 12 and 5, right? So that's my m and n. Now d then would be 12 divided by 5, which is 2.2. And then we round d to the nearest integer. Well, that would be 2. And then we calculate the remainder, which is 12 minus m is 5 times 2, and that's 2. That's the remainder, and indeed that is the remainder. And so this is pseudocode, right? A flowchart has these symbols, and this is the same problem in flowcharts, and you don't have to worry about the shapes and stuff like that. That's for later. You get the two values. Is n less than m? No. So then replace n with n minus m. So I'm going to subtract 1. So notice, and I'm going to replace n with n minus m. So 7 minus 5 is now 2. N is 2. Is n less than m? Yes, it is. So I'm going to output n, and in fact, that does give me the right answer. This is a different algorithm for the exact same task. So one of the things about algorithms is you might have a different process that gives you the same thing. What's neat about this one, it has a looping structure in it that that we didn't see over here. But we can put loops into our pseudocode and into our word algorithms as well. All right, next. What's next? Ways to measure algorithm efficiency. We will not worry about this in any of our courses very much, but just in passing, speed, what algorithm is the fastest? So you think of those two that we just saw before, which algorithm was the fastest? Well, that's a little bit debatable, I guess. Which algorithm uses the least memory? So we could worry about how much space does something take up. And we think of the word checking, the spell checker. Well, does that make sense for you to have the complete English dictionary on every computer? Well, that would take up a lot of space. Well, maybe we should go access a dictionary somewhere online. Well, maybe that would be slow. So the spell checker is an interesting problem. Usually speed and space, usually we're interested in how fast something's more important. Code. What algorithm uses the fewest instructions? Maybe that's what we want to use to measure algorithm efficiency. So this is in our course, we aren't really interested in finding the most efficient algorithm, but only an algorithm that works. However, we can almost always challenge ourselves by trying to make our algorithms more efficient. So this will be one thing that I'm looking for in your programs is, okay, you've got your program solving some problem, but is it a little bit of a strange, hard, confusing solution? Is there an easier way to do the same thing? And usually in our course, we're interested in this one, even though in real life, it's the speed one that we like. Okay, I'm going to stop there, and because this is an example that's going to get us into the exercises, but you don't have to watch the third video because you don't have to watch the example if you don't want to. I'm going to leave that up to you.